What is up guys, and welcome to today's video. And in today's video we'll be covering exactly how this 3D printed egg splatter neon sign was made. We'll be covering everything in this video, from soldering to 3D modeling to the print process, and as well as exactly how you can get access to the files so you can make this project on your own. With that said, I did leave timestamps down below, that way if you want to skip to a certain part in the video you can absolutely go ahead and do so. First things first is that ideally, if you're going to get started with a project like this, you should have some general knowledge when it comes to 3D modeling and as well as to soldering. It will help you out with the process tremendously, as this video is not about tutorials or a beginner's guide or anything of that nature. Although the project is beginner friendly and is fairly easy to create, make, print, and as well as to solder all together. The second thing is that I'll be covering most of the important parts in detail as much as possible, but keep in mind, if I were to completely explain everything from start to finish when it comes to the modeling to the soldering, that would take maybe 3 or 4 hours long, and that would be an entirely long video. So ideally I'll be showing you the brief important parts, my inspiration behind this project, exactly how I 3D model it, the actual assets and the slicing parts, as well as exactly what I did to solder it and put everything together to actually get the final product. So just keep that in mind, and if you want to get more resources and more in-depth guide for this video, I'll leave a link down below with all of the assets that I mentioned. That said, let's go ahead and get started with the video. Okay, so the very first step in this process was finding some inspiration as to exactly how I wanted to sketch the final product, or sketch the product in the beginning and take it into an actual physical item. Now, I just went on Google and searched up egg splatter icon, and it led me to this actual image right here. Now, since we're not using this for commercial reasons or anything of that nature, I just went ahead and screenshotted this on my computer, and then I transferred it over to Fusion 360, kind of acting as my canvas or my layout for the design. So after finding a proper image for our canvas, I went ahead and opened up a new Fusion 360 file and kind of set up the parameters of where I want this to fit into. Since the Ender 3 Pro has a build plate of about 8.9 inches length and width, I went ahead and set up kind of a construction plane with those dimensions there, and then inserted my canvas within that plane there. Now, the whole point of this was making sure that when I'm sketching this and modeling this, that when I actually have the final product, it is actually able to fit within the slicer and as well as within the build plate, because the last thing you want to do is to create a design, especially a design like this with a bunch of curves and not exact dimensions, to not actually fit within the actual build plate or the bed itself, since actually resizing this would actually change the whole structure even if you tried to, and if it was wrong in the first place. From here, I set up some dimensions, some sketches, then I extruded the pieces, making sure that everything we extruded here accounts for actually fitting the actual neon itself, and as well as the wiring for the neon. From here, we only have two pieces. We have the egg splatter white and the egg splatter yellow, which is the actual yolk itself. And since we're only using 2 strips of neon, this project is fairly easy even for most beginners. Now, once everything was sketched out and final, the last thing to do, at least for me, was to add some sort of colors to this design. Now, keep in mind, the colors I added in Fusion 360 are purely for aesthetic reasons. You don't have to add color by any means, and just kind of see exactly what it would look like from head to the actual computer, then to an actual physical thing. From here, we actually added some holes to the design itself, because we want to make sure that we actually could fit the wiring into the design and being able to hide it appropriately. That way, when we actually piece everything together, you don't actually see any sort of wiring sticking out from either the front or on the sides or anything like that. So after completing the design, the next step in this process is to export this to the proper slicer. Now, you'll see me later in the video actually using the Bamboo Lab slicer. Now, keep in mind, I also accounted for the fact that some of you may not have this printer or this slicer, so you'll also be able to use this in Cura or any other slicing software that you guys may not have out there. And I also accounted for the fact that most of you may not have this printer as well, the X1 Carbon, so this should also print just fine on any sort of Ender 3 Pro or any build plate with a 235 by 235 kind of bed dimensions. So after slicing it and adding the appropriate colors to the design, my printer should take about 5 hours to print total. So you'll also see me here check the settings for Cura as well. Now, as you'll see here, you'll see me actually moving the actual design itself and kind of moving it in such a manner where it could actually fit into the actual build plate. Additionally, there's one more thing I like to add to this is that make sure that once you import this actual design that you turn off build plate adhesion. Make sure that you turn that off. You should not have any of those selected other than none. And the reason for this is that it is because if you were to import this project or this design into the actual slicer itself, into, for example, an Android 3 Pro, it actually would not be able to slice, as it actually kind of sits outside the boundaries of those the build plate adhesion dimensions that it sets. So you just want to turn it off and kind of rotate it in such a way where it should fill the build plate. And as you can see here, after slicing it, I get about 7 hours and 30 minutes total print time. But like I said, if you have a 0.6 nozzle or even a 0.8 nozzle and you tweak the settings a bit, I'm very sure you can have a much faster print time to maybe about 4.5 hours. And after about 5 hours printing, here's the final design. I'm going to go ahead and let you guys hear this quick ASMR of me taking everything apart. So now that we have everything we need for the project, it's time to get started into making this into the neon sign. Now, to get started, there will be a couple of things you will need in order to make this project possible. I'm going to go ahead and throw everything up on screen as of right now, as well as provide a list of everything necessary and the things that are optional. Now, keep in mind, there are some things here that you will absolutely need that I'm going to put on screen, and there are some things that you don't need as well. So to get started with this project, we'll first need to cut the neon strips into the appropriate size in order to fit into our actual sign itself. Now, the neon that we're working with is completely cuttable, meaning that it can be DIY'd, which allows you to practically open up and solder new pieces of neon and connect existing colors or even multiple colors, even if you wanted to. And as you can see here, the manufacturer listed a little scissors label on the actual item itself, and that's exactly where you're able to cut, which allows you to cut through it without actually damaging any of the neon lights itself. So this is a crucial step in this process. Once cut, I basically put it all together and slide it into the grooves of the sign itself, and this basically allows me to get a reference point of how much of the neon strip I'll be using, because of course we want to use as little as possible while still getting the best results for our actual sign itself. As you can see here, I take this little tool here and I cut directly right through it. Any pair of scissors will work fine, but anything that's sharp enough to cut right through the silicone strip of the actual neon and the LED strip itself as well. And after a quick cut, you'll see that everything fits nice and snug in there. And now I want to show you guys exactly how this light is powered. Now, if you guys notice on this little LED light strip right here, you'll see that they have a positive and negative sign. That positive and negative sign should be powered by a 24-volt DC power source. Essentially, there's a bunch of them on Amazon. You probably might have one in your house as is. But essentially, if we take that and connect that using a red and black wire, that exposed wiring, essentially, we're basically powering it on using that source there. Now, of course, you need 24 volts since these lights are 24 volts. And you can see once you briefly touch them, they power on. Now, essentially what we're doing here is just testing the wattage here, making sure that light turns on. That's important. And we're also cutting the strips for the yellow one and giving that a quick test as well. Now, the reason why I give it a quick test every single time is because let's not assume that the neon will work perfectly just because I cut it right where the manufacturer says to cut it. There are times where you might have dead zones in the neon lights, and that's totally fine. We want to cut out the pieces rather than go too far in the process and putting everything together only to find out that maybe one of the little lights might not work, which could totally ruin the design. So from here, we're essentially going to set up the wiring for the actual neon itself. Now, as you can see here, the tough part here is actually getting to the actual LED light itself, especially if you're just starting out and you've never done this before. Now, if you decide to do this project on your own, essentially where you want to cut is on the back side of the actual strip, okay, not in the front. Now, as you can see here, as I'm cutting right through it, I'm actually cutting right on the back of it. It kind of glides through. You don't feel a lot of tension or anything of that nature, but if you did, you're probably a key indicator for you to stop or the knife is dull. And the reason why is because you don't want to accidentally cut yourself. Now the thing what we want to do here is actually expose the actual LED lights itself and kind of remove the silicone. Don't take it out all the way, as it's kind of difficult to put it back in, but we essentially want to expose that little piece right there, that little metallic piece there. And we'll go ahead and do the exact same thing for the yellow strip and expose that same part as well. Now depending on the type of neon you got, I basically all got it from the same manufacturer on Amazon, so pretty much they should all be the same in terms of kind of how they are set up. But from here, once they are exposed, I go ahead and get started with the soldering process. Once finished, you should have kind of like these little metallic bubbles that is sitting on the actual metal part of the strip there. And then from here, I'm connecting the red and black wires and soldering them onto the actual strip itself. Now keep in mind, there's still no power source to this neon light right here, so I need to give it a quick test and a quick little check just to make sure that my actual soldering or the actual wiring is properly connected to the light itself. I'm not going to just assume that just because I solder it on that it actually works right off the bat. So before I move on with anything right out the gate, I always give it a quick little test. I always connect it to an outlet really quick just to see and make sure that my soldering is done correctly. So as you can see, once I give it a quick little test, the light turns on. That means all connections are solid. It should be good to go. Then I can properly place everything back into the actual sign itself. Now moving on, I move the actual wiring to come out the back plate of the sign itself, and then from here I move the actual neon into the grooves of the sign. Now the best part about this project is that everything is completely hidden. Now as you can see, once I slide everything inside, you can see that you basically don't see any wiring from the front of the actual design. And from here, once you put everything in, of course you have to give it a quick little test just in case any connections got messed up in the process. And then once the lights turn on, you basically want to give it a quick check, and then you're pretty much good to go. From here, I go ahead and push the actual wiring on the outside of it on the other light itself, because essentially I'm going to connect the white light to the yellow light as that's exactly how they need to be connected to in order to be powered on. After they've been soldered on, of course, I'm gonna put the strip back into the actual silicone piece itself, and I'll go ahead and actually place everything back into the grooves as well. Now the next step in this process is to actually power the actual lights itself, because just because both of the lights are connected and both can turn on doesn't mean that they actually have power at this point. We actually have to have the outlet connect to it directly in order to power it on, power it off, and basically have those ability to function power source. So from here, I'm creating another soldering connection where I actually connect more red and black wires so it can actually stick out from the bottom of the design, and for me to connect it to any sort of outlet when I want to turn it on. So now we are coming to the completion of the entire design, and once you finish, you should have something like this. And of course, we have to give it a quick test just to make sure that it turns on, and once it turns on, that means we're pretty much done and the sign is completely done. And just giving it a quick little inspection around the sides, the edges, just making sure that all the neon is sitting flush within the design itself. Of course, it won't be completely perfect, but the idea it is that we created our own neon sign using 3D printing. Now additionally, if you do or did buy an actual remote, you can connect it to your sign, and that remote will be able to power it on. You'll be able to turn it on, off, dim the brightness, up the brightness. There are a couple different modes and such like that where you can control, and it just gives you the ability to control the sign remotely and wirelessly from basically a small little remote. And that little receiver is just about like $10 or so, so it's a great little add-on, of course completely optional. But I think overall the design looks absolutely stunning. There are virtually no wires sticking out from the front or the sides other than the one that's at the bottom. And you can see that the white light is actually powering the yellow one in the middle, and anyone looking from in front wouldn't actually know that. They would just see the actual light itself, and the only thing is that they would see is the actual wiring from the bottom, because of course they have to power it. So with that said, I hope you guys had enjoyed today's video. Let me know you guys' thoughts and comments down below in the comment section below. If you guys enjoyed this video, exactly what key takeaways you guys learned, and as well as what project should we work on next. That way you guys can give me new ideas as to what I should make in the next video so you guys can make it and you guys can use it for your own projects as well. Additionally, if you guys want to get access to the files and resources that I use for this video, including the STL files, all the assets and things that I purchased on Amazon that you guys can use, and as well as exactly how I was able to model this process and then provide a little bit more in-depth detail to this project, I'll leave a link down below where you guys can get access to that completely free. If you guys did enjoy this video and if you guys want to see more content just like this, make sure to thumbs up this video, subscribe down below. This is Brandon signing out, and I'll see you guys in the next one. Peace.